So since we have understood PCA and also seen how PCA performs, and of course, those of you who are not happy, very happy to see the previous visualization where we could only separate 0 and 1, but not other characters in MNIST, there are a lot of limitations of PCA. Let's go through some of them. Suppose if my data set looks like this, of course, I'll only look at two-dimensional data because that's easy to understand. Suppose we want to project data from 2D to 1D. Okay, let's assume our data set looks like this, right? If I project onto let's assume this was my V1. If I try to project onto this, I'm going to lose a lot of information because this is like a circle, which means my lambda 1 is roughly equal to my lambda 2, right? They're going to be very, very close, which means if I project all of my points, to V1, the information lost, the information or the spread lost is very high, right? So if I have to do it, if I'm forced to convert the data from 2D to 1D, I'll have to lose a lot of interesting information that I'm throwing away, which is unfortunate, right? So if you have data which is like a circle, or in 2D it's a circle, right? What happens in higher dimensional spaces? It becomes a sphere and a hypersphere. If your data is like a sphere, if your data is distributed like a sphere, right? Or a hypersphere in high dimensional spaces, PCA will not do good justice because you're going to lose a lot of information by trying to project the data from a dimensionality of D to D dash, where D dash is less than D. Okay, this is another case. In this case, okay, in this direction there is maximal spread, right? In this direction there is more spread than in this direction, right? My second direction is this, right? So probably my V1 will look like this and my V2 will look like this. The problem here is if I start projecting all of my data, okay, if I project all of this data, okay, so here you'll notice that there are 4 groups or 4 clusters of points. Okay, we'll call them clusters from now. So there are 4 groups of distinct groups of points, right? So when I project all these points, this group of points will get projected. So let me change the color here. This group of points will get projected in this region. Okay, this group of points will get projected in this region. So even the projected points are forming groups. But the problem is with these two. When I project all the data onto V1, these points will be projected in this region. All these points will be projected in this region. These points also are going to get projected in this region, right? Which means these points and these points, which are forming good separated groups or clusters in the two-dimensional space, are being projected into the same region, into this region, right, on my V1. Because all these points will get projected here. All these points also will get projected here. Which means all these, so you'll not be able to distinguish whether points came from this cluster or this cluster, or from this group or this group, right? So by projecting data onto V1, I'm able to, these points are well clustered here. These points are well clustered, but these two sets of points will all fall in this region and we'll be terribly confused. But if I actually saw the data in 2D, yes, I can say, yes, they're two distinct clusters. Probably if for an MNIST data set, this was, let's say, character 2 and this was probably character 3. But the moment I did PCA, all of these are getting crowded together, as we saw in our previous example of MNIST, right? What did we see? We saw that zeros and ones were well separated. Rest of them were all grouped together with making very little sense, right? So this is one case where by projecting onto 1D, I'm losing information. The third very interesting case is this. Imagine if my data followed sort of like a sine wave. Okay, so it has some interesting structure, but now this direction variance is more, right? This direction variance, this will be my V1, this will be my V2. So if I project all of these points onto V1, I've lost this nice, beautiful structure, this sine structure in the data. I'll never see this sine wave when I project all the data to 1D onto V1. When I project all the data, what will I see? I'll just see a bunch of points almost uniformly spread across my V1. I'll never see this nice shape which is actually available in 2D space. If I plotted everything in 2D, I would see this sine wave, which is very, very interesting. But when I visualize the data in 1D, I've lost all that information. Okay, these are some examples of where PCA would fail. If I can recall more, I'll add to this video.